Hey guys, so welcome back to another video. In this video, we are going to see a problem called longest nice substring. Given that a string S is nice if for every letter of the alphabet that S contains, it appears both in upper and lowercase. So, for example, ABB is nice because capital A and small a appear and capital B and small b appear. So however, A, B and capital A is not because the letter B appears and there's no the capital letter in the string S. So for example, in this given string ABB, there need not the alphabets A and B are unique, and as per the given condition, we need to have both of their uppercase letters in the given string, and they need not be in the consecutive order. For example, A and capital A need not be in the consecutive order, so which makes this problem kind of a little bit more complicated. So in this problem, we are going to use recursion to solve it. Let's see how we can do it. So this is the given string, and our logic is going to be something like, so first let's mark the indices 0, 1, 2, 3, 4, 5 and 6. So our logic is going to be something like, so whenever we see an invalid alphabet, we are going to divide the string into two, and we are going to check if the to the left of the string and the right of the strings, if we can find any valid formations, and we are going to return the maximum of them. So for example, in this string we can see that, so we create a set for each and every letter in the given string, so that set is going to be looking like this, and we have all the characters, we put all the characters into the set and we check if they're valid. A character is valid if we have both its upper and lowercase letters. For example, in Y we have both of its upper and lowercase letters in the set, so the character Y is valid. So we kind of going to run a for loop on the string first. So Y, as you can see, Y is valid, and then we move to A, and A we have both the upper and lowercase A's, so it's kind of also valid. And then now we move to Z, but the thing with Z is that we only have its lowercase letter and we do not have its uppercase letter in the set, so it's not valid. So we are going to divide this string into two parts, and it's gonna look something like this. So for example, the string has is it A, capital A and Y, and we're going to divide this string at Z, and we're going to divide it into two, the substring to the left of Z and the substring to the right of Z, and we are going to do this recursively again and again. So the substring to the left of Z is going to be capital Y, and substring S1 is going to be capital Y and small a. And the set, we're going to create another set for this again. So the set is going to contain Y and A. So again, the substring to the right of Z is going to have small s2 is going to be having small a, capital A, and Y, small y. And the set for this is going to be small a, capital A, and small y. So, and then we are going to run for loop on both of these. We're going to do that process recursively and our base case is going to be if the string goes less than 2 strings, then we are going to return an empty string. So it doesn't make sense. So if it goes less than 2 strings, it cannot be a nice string. So we're gonna run a for loop on this string ya, and we do not have both uppercase and lowercase letter y's in the set, so we're going to divide the string into two, and the string towards the left of y, it's going to contain just an empty string, and string towards the right of y, it's going to contain only a. So again, it's less than the length of the string is less than 2, so we're just gonna return an empty string. These both strings are just gonna be returned empty strings, and here we again run the for loop in the string, and for example in ye we have both lower and uppercase letters ye, and again capital A we have both upper and lowercase letters, and again for the small a we have both upper and lowercase letters. So these are valid characters. So we then move to y, and for y we do not have the upper and lowercase letter y, so we are going to divide the string into two substrings again, the string to the left of substring to the left of y, which is this, and substring to the right of y, which is an empty string again. So it's going to be string s1 is going to be equal to a, capital A, and the set for this is going to be equal to small a and capital A, and string to the right of s2 is going to be containing just an empty string, so we don't need to do anything for that. And yeah, this string a, we're going to recursively run the loop, and all these cases, this and this, are just going to return empty strings to the recursion above it, and this special string, which is actually a valid string, it's going to run the for loop on this again. And a, we have both capital A and small a for that, and again for this a we have capital A and small a, and again for the same we have both the capital and small letters. So this is a valid string. So once we find this valid string, we're going to return the string. If the for loop completes, we're just going to return the string. Or if we had another valid string here, for example small b and capital B here, we're just going to compare both of them and return the length of the maximum string. So in this case we're going to return a, and a to its recursion above it, and this is again going to return a to the recursion above it, and so we finally get the answer, which is small a, capital A, and small a, which is the answer. So this is the idea behind it. So let's see how we can code this up. So first I'm going to be creating the recursive call function. It's going to be called dfs, and it's going to be taking one parameter, and it's called string, and we're going to be creating our hash set. It's going to be the set of our current string, and we're going to be creating our base case. If the length of our string is less than 2, then it makes no sense to further proceed, so we're just going to be returning an empty string. And now we're going to be looking to our string for in range of our string if not of string of I dot. If this is going to be checking if our current alphabet is valid in hash set, and string of I dot upper in hash set, then we are going to be dividing the string into two parts. String 1 is going to be the dfs call, recursive call of current string, to the left of our invalid character, and string 2 is going to be the recursive call of the current string, but to the right of our invalid character, and we are going to be returning the string with the maximum length. We're going to be returning string 2 if len of string 2 is greater than len of string 1, else we're going to be returning string 1. And if our string is entirely valid, we're just going to be returning the string and just return the DFS call of s. So this must work. So I'm going to be submitting it now. So this works. So thank you for watching this video. Make sure to subscribe and check the links in the description. Thank you for watching.